evaluate the area of the rows. R is equal to sine 2 theta. So we have 4 pedals of the rows. This is the first, like you may say 0. Theta is from 0 to pi over 2. For such a question, if you say R is between 0 and sine 2 theta, we don't have problem with this. But if you say theta is from 0 to 2 pi and calculate the integral, then you will get 0, which doesn't make sense. The reason for this is R is negative for some intervals, like for theta from pi over 2 to pi, the pedal is not going to be this one, because R is negative. R, which is sine 2 theta, is negative, so you will get this one as the second pedal of the rows. So if you calculate like from 0 to pi, then it will be the result will be 0, because sine 2 theta will have such a graph just like sine x, and this is pi over 2, pi over 4, sorry. It'll be 0 at pi over 2, yeah, pi over 2. So this one is pi, and this is 3 pi over 2, and so on. So if you sketch it on r theta axis, r is equal to sine 2 theta, will have such a graph. So that is why you have to consider only the first pedal. For any similar question for area of rows, you may calculate the area of the first pedal and then multiply by the number of pedals. So for polar coordinates, you have to be careful about the cases where r is negative. When r is negative, it falls below the line, below the axis, so the result will give you something negative. So I will say theta is from 0 to pi over 2. So the area of the first pedal will be 0 to pi over 2, and r is from 0 to sine 2 theta. Integral of dA, remember dA is replaced with r dr d theta. Well, here theta is the last variable. If we start from the inner integral, we will get r square over 2. R is from 0 to sine 2 theta. So this is sine square 2 theta over 2. For integrals of sine square or cosine square, or even powers of sine or cosine, we use power reduction formulas. Cosine 2a, let me say, is equal to 1 minus 2 sine square a. So instead of sine square a, you may write sine square a is equal to 1 minus cosine 2a over 2. So for this specific case, we will have sine square 2 theta is equal to 1 minus cosine 4 theta over 2. So the inner part of the integral is this, and now we have to calculate integral from 0 to pi over 2 sine square 2 theta over 2, which is going to be something like this: 0 to pi over 2 plus sine square 2 theta over 2 d theta. So just replace sine square 2 theta with this expression. You will get 1 minus cosine 4 theta over 2 over 2, so it will be over 4 d theta. So if you integrate, you will get theta over 4 minus integral of cosine is sine. It will be sine 4 theta over 4 because of this 4. You have to divide it by 4, and we have another 4 from the earlier expression. So sine 4 theta over 16, it is going to be 0 to pi over 2. So we have pi over 8 minus sine 2 pi over 16, which is 0, and the other expressions are also 0. 0 over 4 minus sine 0. So pi over 8 unit squares is the area of one paddle. Unit squares is the area of one of the paddles. So just multiply by 4, you will get pi over 2 is the area of the rows. If we have more paddles, then it will be similar, but if it is sine or cosine, you may need to change the bounds for theta. For this one, 0 up to pi over 2 works fine, and then we get this part is pi over 8, and each one is pi over 8, so the total area is pi over 2 unit squares. Please visit the website for a categorized list of my YouTube videos. It is given below in the definition of the video. Subscribe and like.